is our data set: 18, then 13, 25, 21, 10, and 7. Okay. So this 6 data is given. Now we can store them in an array. And what is the way of storing the data element in an array? At first, just declare the array name or the variable, and as well as mention the size. Okay, so here n equals to 6, so we want to store how many elements? 6 elements. And these are their locations in the memory address 0, 1, 2, 3, 4, and 5. So what is the concept of insertion sort algorithm? Sort, that means organize the data in ascending order, and insertion sort, that means take an element from the unsorted array and then insert it in the sorted array. That means the given array will be divided into two halves. One will be unsorted array and another is sorted array. So here, how we can divide the array? Suppose all these elements are in unsorted order, right? We don't know which one is smaller than, or which one is actually lowest element, or which one is the highest element, because we didn't perform any comparison process here. So how we can select the element, that is which one will be stored in unsorted array and which one will be stored in the sorted array. We know that when the array has only one element, at that time that element doesn't need to be compared with the other element, right? Because how many elements the array has? Only one element. So we can consider, or we can assume it, the first element or the element that is in the first memory location, this is sorted. So we can keep it in the sorted array. Okay, so that is our sorted array. And all the other elements in this array are in the unsorted array. So this is our unsorted array. And now here, how many elements you can find in the unsorted array? 5 elements. So each of these elements should be taken from the unsorted array, and after that we can compare it with the elements of the sorted array. Then we can find a suitable place for it in the sorted array. After that, just insert it. So how many steps are involved here? The first step is take an element from the unsorted array. So here there are total 5 elements: 13, 25, 21, 10, 7. So if we take a loop, at that time we don't need to write the same expression again and again, right? So we can take a loop and the loop variable will be I. Okay, so what should be the initial value of that loop variable? Look at the unsorted array. This unsorted array has 5 elements, that is from 1 to 5, right? Their positions are 1, 2, 3, 4, and 5. So the initial value of I will be 1. That means take the first element from the unsorted array, then keep it in a temporary variable. So temp is a temporary variable where 13 can be stored. And after that, now this is an empty space. Okay. So what is the next step? Now we need another loop variable for comparing that data with the data elements of the sorted array. So now we can take another variable j for another loop. And what will be the initial value of j? It will be always 1 less than I. So the initial value of j is I minus 1. So now 13 will be compared to which element of the sorted array? Here the sorted array has only one element, that is in location 0 or position 0. That means the initial value of j is 0 when I equals to 1. So now 13 will be compared with 18. 13 will be compared with 18. So when the element of the sorted array is greater than this element 13, now we can change the location of that element, right? So how we can change the position of 18? 18 is now in position 0, so it will be shifted to the right side and its position will be increased by 1. So now this 18 will be shifted here. It's 25, 21, 10 and 7. So when this element 18 is greater than element 13, okay, 18 is greater than 13, now we can change its location. 18 will be placed where in the right side. Okay, so since there is no other element in the sorted array, that means this location 0 is the ideal place for the data element 13, right? So in this way we can take all of these elements from the unsorted array and then we can compare them with the element of the sorted array. After that, when we find the suitable place for these elements, we can just insert them in the sorted array. And that was insertion sort, right? Hello.
Yes, ma'am.
Is it clear what is insertion sort? It was our last day's discussion. We discussed about this algorithm in the last class. Is it clear?
Yes, ma'am.
Yes, madam.
Okay, so if insertion sort algorithm is clear, then we can move on to the next one, that is selection sort algorithm. Okay, so the main purpose is to organize the data in ascending order. But now the name of this sorting algorithm is selection sort. In the previous one, in the insertion sort algorithm, we just picked one element from the unsorted array and then we just found we just performed some comparisons for finding the correct right place for that element and then we inserted that element in the sorted array. But for this one in selection sort algorithm, what is the name? It's selection. That means we have to find out which one is the lowest element of that array. Suppose we can use the same data set with 6 elements 18, 13, 25, 21, 10, and 7. So this is our array with 6 elements. So here n equals to 6. And their positions are 0, 1, 2, 3, 4, and 5. Okay. So why we are conducting this algorithm? For arranging the data in which order? In ascending order, which means that the lower data element will be placed first, right? So among those 6 elements, which one is the lowest data element? Obviously 7. That means in the sorted array, at first we have to keep 7. After that, the element which is greater than 7, that is 10, and then 13, 18, 21, and the last one will be 25. So that will be our sorted array, where the smaller data elements are placed first, and then in the last position, we can find the highest data element. So this is our sorted array. So in selection sort algorithm, how we can select the lowest data element from the 6 data. We know that 7 is the lowest data element, and what we did in the insertion sort algorithm, there we divided the array into 2 halves. One is the sorted array, another is unsorted array, and then we compare each element of the unsorted array with every element of the sorted array. That was the concept of insertion sort algorithm. But here we can also divide this array into 2 halves. Okay, suppose these 18, 13, 25, 21, 10, 7, all these 6 data elements are placed in the unsorted array, and initially the sorted array is empty. That means we didn't insert any element in the sorted array. Okay, so if the whole array is our unsorted array, now what will be, we need to conduct a loop here, right? Because we have to sort how many elements? 6 elements. We have to place 6 elements in their correct positions, right? So we can conduct a for loop, and what will be the initial value of for loop? Obviously 0. When I equals to 0, we can assume that 18 is the lowest data element of this array. The data element 18 is placed where? In the location 0. So you can assume that 18 is the lowest data element array. Okay, so now we can take another variable that is minimum, and we can say that we can assign the value of this variable I to that variable minimum. What is the first step of selection sort algorithm? Here we just have to select, we have to find out which one is the lowest data element. Okay, so So initially we can assume that this one, the first data element, is the lowest data element. So in for this loop, for a for loop, we can take a variable I, and what will be the initial value of I? 0. I equals to 0. Okay, so now if we assume 18 as the lowest data element, now we can assign that data, we can assign that value to another variable minimum. Okay, so minimum equals to 0. That means here we are actually storing the value of I. So we can write minimum equals to
I.
I. Is that clear?
Yes, ma'am.
Okay. So now we just assume that 18 is the lowest data element, but still we don't know whether we can find some other elements which is smaller than 18. Okay, that's why we have to compare this element with all the other elements of the unsorted array. Okay, so for this comparison purpose, we need another variable, right? Suppose that variable is j. At first we just picked one element, or we just considered the first element as the lowest data element, and now we have to find out that actually is this the lowest data element. I will find it out by comparing the data element with the other data element. So now we need a loop, and what will be the initial value of that variable j? Obviously I plus 1, I plus 1, because this 18 is the lowest data element. Now we can compare it with the data element 13. So if I equals to 0, then the initial value of j will be I plus 1, that is 1. Clear?
Yes, ma'am. Got it.
Yes, ma'am.
Okay, so what is the next step now? We have to check whether this data element is less than the data element which is or which was assumed as the lowest data element. Now, what is the next condition? We have to check whether this 13 is less than the data which is stored in the minimum variable. Here, minimum equals to I and I equals to 0, right? So here, if the name of the array is 0, that means A0 or A minimum equals to 18. So is this condition true or false? 13 less than 18
True.
is true.
True. True.
So if it is true, that means the value of minimum should be changed, because now this 0 is not the location of the lowest data element, because we just found that 13 is lower than 18. So how we can change the value of this minimum variable? Here in this variable, we will always store the position of the lowest data element. When we compared the lowest data element 18 with another data element 13, now we found that 13 is actually lower than 18. That means the value of minimum will be changed. So what will be the value of minimum now?
I plus 1.
Or minimum equals to j, because I plus 1 is the value of j, right?
Yes, ma'am.
So here we can write minimum equals to j. That means the new value of minimum will be 1.
1.
The value of minimum is now 1, which means that 13 is the lowest data element of this array. But still, it can happen that maybe some other data elements are lower than 13. That's why we have to continue, we have to execute the inner loop one more time. Okay, so now after this incrementation, j plus plus, what will be the new value of j?
2.
J equals to 2, right?
Yes, ma'am. Yes,
So
ma'am.
now that value will be compared with the value that is stored in minimum variable, right? So now in minimum, which value is stored? The location is 1. That means here 13 is the lowest data element, isn't it? And what is the new
Yes, ma'am.
value of j? J equals to 2. That means now 25 will be compared with the minimum value 13. And what was our condition for changing the value of minimum? The condition was if aj less than minimum, then we can change the value of minimum. But here, this aj is actually greater than minimum, isn't it? That means still this minimum equals to 1, that is true, because 13 is smaller than 25. Is that clear? Why we didn't change the value of minimum?
Yes, ma'am.
Okay, so after that, when Still, 1 is the minimum location. I mean, 13 is the minimum value. Now we have to compare it with another value of the array, right? That means again j plus plus. So what is the value of j now? J equals to 3.
3.
So after that, we will compare the data element that is in minimum variable, okay, with the data element 21. So this is aj. When j equals to 3, aj equals to 21, and the minimum is 13. And what is the condition? The condition is if aj less than 13, then change the value of minimum. But here we can see that aj is greater than minimum, which means that still this one is actually the lower element. 13 is the lowest
Lower.
element. Then again j plus plus. Now when j equals to 4, 10 will be compared with 13. Right? Now the next comparison will be we can compare 13 with the minimum value. Sorry, 10 with the minimum value 13. So here in this step, this condition is true. Now aj is less than minimum value. So at that time, the value of minimum will be changed. And for which data we got this condition true? For the data 10, isn't it? And 10 is stored in the location 4. So now the new value of minimum is 4. Which one is the lowest element now?
10.
10. Okay. So now again j plus plus, that means 10 will be compared with which element? The next one, 7. So now this is aj. When j equals to 5, aj equals to 7. And from minimum variable, we got that 10, right? So now check the condition. Is it true or false?
Yes, true, ma'am.
True. So if it is true, that means again the value of minimum will be changed. Now minimum equals to 5.
5.
Is that clear?
Yes, ma'am.
Okay. So now look at this. We already compared all the elements, isn't it? 7 was the last data element. So after comparing these 18, that was our initial lower element, isn't it? The initial value of minimum was 0. That means 18 was the lowest element. And after comparing it with all the other data elements of the array, now we got that this 7 is the lowest data element. After that, now we have to perform a swapping. Which two data elements will be swapped now?
18 will be swapped with 7.
Very good. 18 with 7. Because initially 18, we assumed that 18 is the lowest element, but now we found that 7 is actually
7 is the.
right. So now these two elements will change their position. So here, this is the next step. So these are location 0, 1, 2, 3, 4, and 5. Okay, so now 7 will take the position of 18. So here we can store 7, and 18 will be stored in the location of 7. So here, okay, it's 13, 25, and 21, 10. Is that clear?
Yes, ma'am. Yes.
And so we can call it the first pass or pass number 1. And after one pass, we could place one data in its correct location. Now, this location 0 is the correct place for 7. Okay, that means this is our now sorted array with one element. Okay, so now this is our unsorted array. Okay, so in the second pass, in pass number 2, so which one should be assumed as the lowest data element?
13.
13, because here the value of I was 0. So after changing the location of these data elements, now the value of I will be increased. So for this one, for the second pass, the value of I will be 1. Okay. So that is 7 in the sorted array, and this is our unsorted array. So 13, 25, 21, 10, and 18. Okay. So now when I equals to 0, that means the minimum value will be 1, isn't it?
Yes, ma'am.
So here I equals to 1, and the next step is this 13 will be considered as the lowest element. So we can write minimum equals to 1 because minimum equals to I. Okay, now what is the next step? For each
Comparing.
value of I, we have to conduct the inner loop. That is now what will be the value of j? J equals to I plus 1. That means 30 will be compared with 25. So when minimum equals to 1 or I equals to 1, j equals to I plus 1, that is 2. Okay, and what is the condition? If aj is less than minimum, so what will happen? Here aj, that is a2 equals to 25 and minimum equals to 13. That means this condition is not true. This is aj, a2 equals to 25 and minimum equals to 13. So 25 is not less than 13. That means it's not true, isn't it? So if it's not true, that means the value of j will be increased. Now we have to compare the minimum value with the next element of the array. Okay, so now j equals to 3, so we can compare 21 with minimum, that is 13. So again, the condition is not true. 21 is not less than 13. So again, j plus plus, so 13 will be compared with 10, right? So here we can, sorry. So here now, 10 is less than 13. When j equals to 4, we can compare 10 with minimum 13, and now the condition is true. 10 is less than 13, and when aj is less than minimum, change the value of minimum. So now 10 will be the lowest element. That means minimum equals to 4. Is that clear? When the condition is true, that means now the new value, the lowest data element is not 13. It's actually 10, and 10 is stored in where? In location 4. So minimum equals to 4. Okay, now the next again j plus plus. So now 10 will be compared with the last data element 18. So now 18 is the value of aj when j equals to 5. And what about minimum? Minimum equals to 4. That means 10 is the minimum data element. And here the condition is not true. 18 is not less than 10, isn't it?
Yes, ma'am.
Okay, so now which two data elements will change their position?
4 will be swapped with 13.
Very good, because here the condition is not true. That means we didn't change the value of minimum. So 10 is the lowest data element, and but we assume 13 is actually the lowest data element. Initially, when we started this pass, the second pass, at that time we assumed that 13 is the lowest element. But after comparing it with the other elements, we got that 10 is actually the lowest element. So now these two elements will change their position. So now 10 will be stored in position 1, and 13 will take the position of 10. Isn't it? So in the second pass here, we can write 10. And this 4 is a location of 13. So after the second pass, now it will be the length of sorted array. Now we have placed two elements, that is 7 and 10, in their right position. Is it clear?
Yes, ma'am.
Okay. So after that, now this is the size of the unsorted array, right? So which element will be compared now? 25. So in the third pass, or when I equals to 2, that means the value of minimum is 2, right? So 25 is the lowest element. Okay, so when I equals to 2, what is the value of j? J equals to I plus 1, that is 3. Now compare aj with a minimum. What is the value of aj? Aj equals to 21, right? And what about minimum? Minimum equals to 2, that means 25 is the value of a minimum. So now test the condition. The condition is If aj less than minimum, then change the value of minimum. So here aj is less than minimum, that means 25 is not the minimum data, right? So the new value of minimum will be
3.
right. So now 21 is the minimum or lower data element. After that, j plus plus, that means the minimum value 21 will be compared with 13. Now the comparison is between 21 and 13. So aj equals to 21 and a minimum equals to 13, where the condition is not true. So if the condition is not true, that means still 3. That means 13 is the lowest data element. After that, j plus plus, that means compare it with the next data element 18. So here when we are comparing 13 with 18, again the condition is not true, right? So 13 is the lowest data element. Now we can change the position of 25 and 13. So in the third pass, 13 will take the position of 25. So that is 7, 10, then 13, 21, and where we can place 25 in position 4. So that is 25. The last data is 18. So now, how many elements are sorted? What is the length of the sorted array now?
4, ma'am.
Why 4? Only 3. That is 7, 10, and 13. These 3 elements are now in their correct position. After the third pass, 3 elements are placed in the correct location. Is it clear?
Yes, ma'am. Yes, ma'am.
We need to, we need how many passes actually for sorting all the other elements of this unsorted array? In the same way,
We need 3 more. 2 more, ma'am.
2
We
more.
need 2 more.
Because after the fourth pass, another element will be sorted, right? And after the fifth pass, 5 elements will be sorted. That means after the fifth pass, 1 element will be left and that element will be placed in their correct position. We don't need to actually compare it with the other element, isn't it? Because when the array has only 1 element, it's automatically actually placed in the correct location. Is that clear? That means when the number of data is 6, we need how many passes? 5 passes, just like bubble sort algorithm. Right?
Yes, ma'am. Yes,
Do
ma'am.
I need to show the other passes, pass number 4 and 5? Or you can... Hello?
Yes, ma'am.
Yes, ma'am.
Hello? Hello?
Yes, I'm just asking, do I need to write all the other passes, that is pass number 4 and 5? Do I need to show how the data will be changed?
No, ma'am. We can.
What about the others?
Yes,
No, we can, ma'am.
Okay. So that means in selection sort algorithm, we are just selecting the lowest data element. Okay. So how we are actually taking the lowest data element? We are just randomly picking an element, isn't it? Is this true that we are randomly picking the element?
Ma'am.
No. This is
No,
like linear search process. Linear search process, right? We are just taking an element from the first location and then we are comparing it with the other elements for just checking whether the taken element is actually the lowest element or not. And when you are finding another element which is smaller than the previously taken element, and then we are just changing the value of the lowest data element, isn't it? So in this way, after finding the lowest element, we are placing it where we are placing it. Just look at the first step. 18 is the lowest element, right?
Yes, ma'am.
Yes, ma'am.
And after that, when we perform some comparison operation, after that we found that 7 is actually the lowest element. And then how we are changing the location? We are changing the location of newly found lower element with the previously taken lower element, isn't it?
Yes, ma'am.
So in this way, we can change the location of all the other data elements, right?
Yes, ma'am.
Right, ma'am.
Can you tell me what is the basic difference between insertion sort algorithm and selection sort algorithm? or what is the similarities between bubble sort algorithm and selection sort algorithm? The similarities between insertion sort and selection sort algorithm is the array can be divided into two sub-array. One is sorted and another is unsorted. Right? And then in insertion sort algorithm, we are how we are actually sorting the data. In insertion sort algorithm, we are just taking an element from the unsorted array and then we are comparing it with the element of the sorted array, not with the other element of unsorted array. That was insertion sort. At first, the array will be divided into two halves, and one half will have the elements or sorted elements, and in another half we can place all the unsorted element. And in that algorithm, we didn't compare the unsorted element with the other unsorted element. The comparison was between one unsorted element with the other sorted elements, isn't it?
Yes,
And
ma'am.
what about the selection sort algorithm? Here, initially, or we can divide the array into two sub-array. One is sorted, another is unsorted, but the sorted array is empty. Okay, so now we can pick an element from from this array, and we have to assume it as the lower data element, lowest data element. Then you can compare it with the other elements of the unsorted array. And after getting the lowest data element, we can keep it in the sorted array. That is selection sort algorithm. We are just selecting the lowest data element. Okay, so after each process, we can find one lower element and we can keep it in the sorted array. Is that clear?
Ma'am,
Yes.
we can say that the bubble sort is just exchanging.
Actually, bubble sort algorithm, we can find so many similarities between bubble sort algorithm and selection sort algorithm. Right? In bubble sort algorithm, how we perform those swapping? In bubble sort algorithm, we are just taking one element and then how we compare the element. For each process, there are a number of comparisons, isn't it? In bubble sort algorithm, we just compare two adjacent data elements. Suppose 18 with 13, after that 13 with 25, then 25 with 21, 21 with 10, 10 with 7. Right? And
Yes, ma'am.
after one pass or after a number of comparisons inside one pass, we would place only one element in the correct position. But here, inside this pass, we can make all the comparisons here inside one pass. But we don't need to actually show that process individually. Right?
Yes, ma'am.
So, what is the time complexity of selection sort algorithm? For bubble sort and insertion sort algorithm, the complexity was order of n square. But before that, actually, we can write the algorithm. Okay. So this is our data set with 6 elements. That is 0. First one was, what was the first data element?
It was 18 so far.
Okay, after that,
Third,
And
no,
13, and then third one,
21. Oh, 25.
5,
21,
1,
10,
10,
10.
then 7.
and 7.
Thank you. So this is our array, okay, where n equals to 6. Okay, so how we can start the algorithm? All the processes are discussed. So now we just have to write some statements, some expressions. Okay. So how many variables we need here? One is array variable, another is n, and if we need two loops, then the number of loop variable will be 2, I and j, and then we need another variable minimum. So these are the variable. Okay. So now we can start the loop. And that is our outer loop, which will be used for taking the lowest data element. Okay. So if I is used here, so how we can initialize it?
I equals to 0.
Equals to 0. Very good. We can take the first element, so I equals to 0, and what will be the condition?
I less than
N
equals
number
to
of
n.
elements, and here we have to check all the elements. So what will be the condition of I?
I less than or equal to n. Less than, yes, less than.
Less than n.
n minus 1.
Very good. I less than n minus 1. Because for n number of elements, and if we start from the location 0, how many times or how many passes we need? N minus 1 number of passes.